Hello and welcome. This is going to be our homework help video for all of the final reviews for Algebra 1A for this second semester. So I'm not going to do every single problem. I'm just going to try to pick out just the hardest ones, try to keep this under an hour. All right, continue each pattern with the next two numbers. So first we want to see if it's an adding pattern or a subtracting pattern. So we're just going to write what we're adding by. I'm right here, I'm adding by 7. But then here I subtract 6. Then I add 8. Well, then I subtract 6 again, and then I add 10. And then I subtract 6. So the only thing that is constant here is that every other time I subtract 6. So these ones aren't the same, but every other one I subtract 6. So next we check to see if it's a multiplying pattern or dividing. So for these intermediate ones, 7 to 14, I can get there by multiplying by 2. Let's see if that works for the next alternating pair. 8 to 16, yep, that's times 2. 10 to 20, that's times 2. So the next one would have to be a multiplication step since we just subtracted 6. If I multiply by 2, I get 28. And then I should subtract 6, 22, multiply by 2, 44, and so on. All right, so that's problem number 1 there. I remember doing this one in class, so I think maybe the pattern down here for numbers 8 and 10 would be a good one. What are the next two terms in this sequence? Well, let's check and see if it's an adding pattern first. To get from 6 to 13, I add 7. To get from 13 to 20, I add 7. And to get from 20 to 27, I add 7. So yep, it's an adding pattern. And then I just have to keep adding 7. So 27 plus 7 gives me my next term of 34. And then, make that look more like 34. And then 34 plus 7 equals 41. So next two terms, 34, 41. Create a table to determine the algebraic expression for this sequence. So create a little XY table. Now I leave a blank in my XY table because I don't know what the 0th term is, but I know what the first term is. The first term was a 6 followed by a 13. So the first term is a 6, the second term is a 13, the third term was a 20. So to move forward in this list of x values, I add 7. To move backwards, I've got to subtract 7. So 20 minus 7 is 13. 13 minus 7 is 6. 6 minus 7 is -1 for my 0th term. So I had to subtract 7 there. Now, I need an algebraic expression. So this -1 is good because that gives me my b. And the fact that I have to add 7 each time gives me my m. So I get y equals mx plus b becomes y equals 7x minus 1. -1 right there. What would be the 15th term of this sequence when I can just plug 15 in for x? Y equals 7 times 15 minus 1. 7 times 15 is 105. So 105 minus 1, which equals 104 for the 15th term. So much easier to use the formula than to try to just keep listing these out all the way to the 15th term. All right, number 11, look for the pattern. Let's see. I added 6 there, then I added 6, then I added 6, but this last one did not add 6. I wonder if that's almost just a typo. Well, none of the options are. add 6 each time. So let's just see which of these makes sense. Multiply x by 10 to get y. Well, that works for the first one, but not the rest, so no. Multiply x by 2, then subtract 1. Nope, that doesn't work. Multiply x by 3, then add 4. So 2 times 3, that's 6. Add 4, yep, that's going to be the one that it is. And multiply by 5. I got tripped up here because I thought this was counted by 1s, but it's counted by 2s until the very end where it counts only by 1. So that's why it didn't look like it was consistent, but it really was. All right. Let's just do number 11. Bell rings at 55, 40, 25, 10, 10. Explain how you can find when the next bell will ring. Well, they're each spaced out by 45 minutes, so just add multiples of 45 minutes. So the next bell will be at 10:55 and then at 11:40. All right, next homework. Number 2, solving equations fundamentals. Quotients look like this. They're division, difference. We write with subtraction. Squared is the little number 2 up top, and product is the result of multiplication. So we write 2 times y. You definitely need to know those words. Also know the word sum, which tells us to add. Simplify each expression. Let's just skip down one of these hard ones that we'll use all of our skills on. For number 10, we got to distribute this 2. We know we have to distribute because we have a number in front of a set of parentheses. Remember to distribute the negatives with these. And let's see what we get. We get negative 16a minus 2 minus 8 plus 48a. Now there's no more parentheses, so the only step left is to combine like terms. 2 things are like terms if they've got the same variable with the same exponent. So this negative 16a and this 48a are going to become a 32a, and this negative 2 and this negative 8 are going to become a minus 10. All right, let's practice our solving skills with, I'll try to pick a difficult one, maybe like, let's do 17, then we'll do 19, because they both show division in a different way. In 17, this addition is outside of the fraction, so this is our most outside operation, and I get rid of it first with a minus 10 on both sides. And now I've got a over 4 equals negative 1. Now I can multiply both sides by 4, and I get a equals negative 4. In 19, this addition is inside the fraction, so we need to get rid of the division first. The division is the most outside operator. So we get rid of that with a times 17. So we multiply 17 to both sides, and we get r plus 19 equals 34. Subtract 19 from both sides, and we get r equals, let's see, 34 minus 19, 15. All right, and then let's just do one of these that has multiple spots to distribute. I guess we'll start with 23 looks pretty difficult. Let's distribute that negative 7 and that 5. See what we get. We get negative 76 equals negative 56 plus 28n minus 20 plus 35n. Negative 76 equals, combine like terms, 28 and the 35. When I add those together, I get 63n minus 76. When you add 76 to both sides, and we get that 0 equals 63n, divide both sides by 63. 0 equals n. Okay, so let's do one where we've got some like terms to combine. See one that might have no solution. That'd be a good one to get. I guess we'll just finish with number 30. Well, and then we'll do one of these proportions. All right, number in front of a set of parentheses, we distribute that. 7x minus 32 equals negative 35 minus 35x plus 3. These are like terms, we're going to combine them. So we had 7x minus 32 equals negative 32 minus 35x. Got variables on both sides, so I moved the smaller one. And I think of this negative 35 as smaller because it's because it's negative and this one's positive. So I go after the negative, and that way I ensure that my x value is going to be positive because I add 35x to both sides, and now I get a nice positive 42x over here. Minus 32 equals negative 32. Add 32 to both sides. We have 42x equals 0. Divide both sides by 42. X equals 0 here as well. That, I have an answer key here. Yep, number 30 was 0. And I don't see any that have no solution, so we don't have to go over one of those. Let's go over the proportion at the bottom here. In order to solve a proportion like number 33, we start by cross multiplying. Well, actually, 33, you could cross out these 8s, and now you just have r equals 8 over 9. And you're done there. Let's look at 34. So cross multiplying, you multiply like this and create a new equation. 2 times 4 equals 5 times v. So we get 8 equals 5v. Divide both sides by 5. And we get about 1.6, or 1 3/5 equals v. All right. Let's double check that. 1.6. All right. Fractions. Simplify each fraction. Let's pick a big one, like 7. When I'm simplifying, if they're both even, then just get rid of that 2 by dividing the top and bottom by 2. 72 over 45. Now they're not both even, because 45 is not even, but maybe they're both divisible by 3. By the top and the bottom by 3, and we get 72 divided by 3 is 24 over 15. Again, they're both divisible by 3, so I can divide the top and the bottom by 3. And I get 8 over 5. To write this as a mixed number, we ask how many times 5 fit into 8? 1 time with 3 left over. 1 3/5. Find each product. All right, to multiply two fractions, you multiply across the top, then you multiply across the bottom. Let's do one like number 13. I'm going to turn this into a negative 2 over 1. I'm going to put the negatives here on top of their fractions. This is going to create the equation negative 2 over 1 times negative 6 over 7 times 3 over 4 times negative 1 over 7. Now I got to multiply all the way across the top. Let's see, negative 2 times negative 6 is positive 12 times 3 is 36 times negative 1 is negative 36 over 7 times 4 is 196. Now I look for a way to simplify this. Definitely divisible by 2. So bottom becomes a 98. Top becomes a negative 18. Still divisible by 2. Top is now a negative 9 over 49. And I think at this point we are done. Negative 9 over 49 for 13. Yep. All right, so that's how we multiply. Time to divide. To divide, you need to copy dot flop. So let's just do one like 17. So I copy the first fraction, negative 7 over, or negative 2 over 7. I replace the division with a dot for multiplication. And then I flip the other fraction, so now it becomes 7 over negative 5. Before I multiply these, I could just cross out these 7s. That's called cross simplification. And now also these negatives can cross out. And I'm left with 2 over 5. All right, in order to find a sum, you need to get a common denominator. So let's look at one like 22 here. A guaranteed way to get a common denominator is to multiply the first fraction's bottom by the bottom of the second fraction, and the second fraction's bottom by the bottom of the first fraction. All right, so now they'll both have a 40 on the bottom because I multiplied this by 8 and this by 5. But whatever I do to the bottom, I have to do to the top. So I'm going to multiply this one by an 8, this one by a 5. Now I've got 56 over 40 plus a negative 75 over 40. This here equals a negative 19 over 40, which is our final answer, 22, negative 19 over 40. All right, difference is very similar. You got to get a common denominator. Let's try 26. So you have to do an extra step here. You have to turn this into a 2 over 1. The minus and negative can cancel out. So now I've just got 2 over 1 plus 3 over 2. Multiply this side by 2 over 2 to get now 4 over 2 plus 3 over 2 equals 7 over 2. And for these ones, we can just leave it as an improper fraction. Unless you're specifically told to switch it into a mixed number, just leave it as an improper fraction. All right, let's do a couple of these. Maybe like 28. So before we can simplify the big fraction, we got to simplify what's on the bottom here. The 2's can cancel out and the 3's can cancel out. You got to leave something behind. Well, in this case, you don't really, but we'll leave a 1 behind. 7 over 5 divided by 1 is just 7 over 5. Here, with this big fraction, we are going to copy dot flop that. So now it becomes 8 over 5 times, I'm going to take the 3 over 4 and flip it to be 4 over 3. Still squared. This here equals 32 over 15 squared. And then you're going to square the top and square the bottom to get 32 times 32 equals 1024, and 15 squared is 225. I don't think that can be simplified, but let's take a look. 29, nope, yep, 1024 or 225. All right, simplify. Your answers should contain only positive exponents. How we do this, let's do like problem 3 here is we first expand the exponents. So 4 times a times a times a times a for the 4 a's, and then 8 times a times a. And then we cross out one from the top, one from the bottom until we run out of numbers to cross out. A times a is going to become a squared. And then the 4 and the 8, they can both be divided by 4. Let me make that confusing if I write it like that. We're going to divide the top and the bottom by 4 to get final answer a squared over 2. 4 divided by 4 is just a 1, so we don't have to write that. A squared over 2. Yep. All right. Number 4, equation between 2 points. Write the slope-intercept form of the equation of each line. So I look where it's crossing my y-intercept. That gives me my b value. B is equal to -2. And then I create a slope triangle to find the slope. So make that point there and this point here. Connect them with a right angle triangle. This one has a run of 3 and a rise of 1, 2, 3, 4. So rise over 1 is 4 over 3. That's my m. Put it together into equation. Y equals 4/3 x minus 2. All right. With just a horizontal line like this is just y equals -2. You have to remember y equals equations create horizontal lines. All right, let's do one of these. We'll do number 7. Write the slope-intercept form of equation of the line through the given points. I'm going to label this x1, y1, x2, y2. All right, then use my slope formula to find the slope between these points, so y2 minus y1 over x2 minus x1 equals 2 minus 5 over 4 minus -2, -3 over 6, we simplified to -1/2. That's my m value. Now that I've got the m, I'm going to write out y equals mx plus b. Then I'm going to borrow one of these points. I'll pick the 4, 5 to help me solve for b. So I'm going to use that m value and 4, 5 to solve for b. So 5 equals -1/2 times 4 plus b. 5 equals -2 plus b. Add 2 to both sides. 7 equals b. That's my b value. I've got my m value. I put that together into one final equation. Y equals -1/2 x plus 7. All right, then we just got a bunch more of these. Let's take a look at the answer key, see if that makes me want to do one of these. Maybe number 11, because it's kind of interesting. All right, so if I do my slope formula, x1, y1, x2, y2, I get -1 minus -1 over 4 minus -3. Well, this is -1 plus 1, which is 0 over 7 equals 0. So with the slope of 0, I could plug it into my equation, but I can just realize, oh wait, this is a horizontal line. So I just have to have it be y equal to the y value of either of the points. They're both -1, so just y equals -1. All right, we're about halfway through. Just want to check video software. Looks like it's recording still. All right, number 5, graphing linear. Write the slope-intercept form of the equation of the line given the following slope and y-intercept. So if you're given a slope and a y-intercept, you just fill them right into y equals mx plus b. So y equals 1/3 x plus 4. Here we have some equations in standard form. The system for converting standard form to slope-intercept form is the same every time. Let's try it with number 8. We move the x term to the other side by subtracting it. Minus 13x minus 13x. Here it will cancel. We'll be left with a 4y. And on this side, we put it in front of that -20. So -13x minus 20. Then you divide by the coefficient of y, divide to every term. And we get y equals, and then I want to pull the x off the top of this fraction, right? It's just a -13 over 4x, and then 20 divided by 4, that's going to be a -5. A bunch more standard form to convert. Sketch a graph of each line. We put a point at its slope at its y-intercept of -2. The slope is -1, so I go down 1, right 1, down 1, right 1, down 1, right 1, all the way across the graph, or up 1, left 1 to continue with this direction. Very important skill, graphing lines using a slope and a y-intercept. Looks just about right. All right, let's try another one of those, maybe with a slightly harder setup. Even 12 looks a little bit better. Y-intercept is -2. From that point, I need to go up 3, right 2, up 3, right 2, because that's what the slope's telling me to do. Go off the graph so I can go now down 3. That's weird. Down 3, left 2. And connect those up. All right, x equals -1. Vertical line at -1. We need to know that x equals equations to create vertical lines. And then here we're going to put our skills together because it's in standard form, but we have to graph it. And the easiest way to graph it is to convert it back to slope-intercept form. So let's just copy it down with some space. 5x plus 4y equals -16. Subtract 5x from both sides. We get 4y equals -5x minus 16. Divide every single term by 4. Y equals -5/4 x minus 4. Now I come to my graph, I put a point in my y-intercept of -4. From that point, I would like to go down 5, right 4, but I can't. So I reverse that. I go up 5, left 4, and I get another point. And then I do my best to connect those up with a straight line. Pretty good. All right. On to review number 6, parallel and perpendicular lines. Find the slope of a line parallel to each. Well, when it's parallel, it's just the same. You see where I'm getting these numbers? I'm just copying down the slope. Gets a little bit harder here because this isn't in slope-intercept form. I got to subtract 2x from both sides. Get y equals -2x minus 5. So the parallel slope is -2. And over here, same thing. Subtract 5x from both sides. Y equals -5x plus 1. So the parallel slope is -5. Perpendicular, that's a little bit harder. So what I do is I need the opposite reciprocal. So I take the coefficient here, I got to flip it upside down and make it opposite. This one's positive, so I'm going to make it negative. Take that 1/2, make it a 2/1, make it negative. This simplifies to be just -2. Here the slope is -1. The opposite reciprocal of -1 is a +1. Opposite reciprocal of -1/4. Well, I flip that upside down, it becomes 4/1. This one's negative, so the opposite reciprocal is 4 over +4/1, which simplifies to just be 4. This is going to be a horizontal line. Its perpendicular line would be vertical with an undefined slope. And this one, I'd have to subtract 7x from both sides. Get -5y equals -7x plus 25. Divide both sides by -5. Get y equals 7/5 x minus 5, and then find the reciprocal of that 7/5, which would be -5/7. All right, let's do one of these. So if it's parallel to y, so write the slope-intercept form of the equation of the line described. It's through the point 5, 5, and is parallel to y equals 2x. So that's going to give me an x and a y I can borrow. And this here gives me my m. It gives me the m value because parallel lines have matching slopes. So I know that the slope has to be m here. It's got to be 2. Equals mx plus b. I get 5 equals 2 times 5 plus b. 5 equals 10 plus b. Subtract 10, subtract 10. negative 5 equals b. Now between this value and this, I can write my new equation, y equals 2x minus 5. Next problem. All right, so we'll do 16. Again, they give me an x and a y, but it says it's perpendicular to this. So this is not my m. I've got to change this. This becomes negative 4 over 3, the opposite reciprocal. This now is my m. So start with y equals mx plus b. That's going to become 0 equals negative 4 thirds times 3 plus b. 3's cancel out. 0 equals negative 4 plus b. Add 4 to both sides. 4 equals b. And now we're at the equation y equals negative 4 thirds x plus 4. And we've got just more solving. We already did a lot of that this video. Let's see if any of these look like they're much different. Let's see, do we have maybe a no solution or something? One. No, I think that they're pretty similar to what we were doing earlier, so I'm just going to keep moving. On to number 7, systems by graphing. It starts with a little converting standard form to slope-intercept form. It's a very useful skill. Time to solve these systems. So there's an infinite number of points that will lie on this line and make this equation true, and another infinite set that will make the second equation true, but is only one point will make them both true at the same time. And that's where, if I graphed all the solutions to both of these on a coordinate plane, it's the point where they intersect. So let's just graph them both. Y-intercept of 4, slope of 7 over 3. So I want to go up 7, right 3, but I can't. So instead I go down 7, left 3, and make another point. Connect those up with a solid line. Next line, got y-intercept of negative 1, slope of 2 over 3, so I go up 2, right 3. I go off the graph, so now I go down 2, left 3, and we see it hits that same point. So I connect this up with a line. And I get that the only point where they intersect is right here, but I have to write the name of that point. That point is at negative 3 for the x, negative 3 for the y. So negative 3 over 3. 3 look better. All right. So these all look pretty easy to graph. Let's see if there's maybe some harder cases. Yeah, here we got some that are in standard form. So you got to convert them both to slope-intercept form, and then graph them both, and then find their intersection point. So let's do the one that looks like it's got the biggest numbers. I'm going to do 10 to start. Yeah, I like 10. So here we've got 4x minus 3y equals 6. Same steps to convert this into slope-intercept form each time. We move the x value, negative 3y equals negative 4x plus 6. And then we move the coefficient for y by dividing it to every single term. Y equals 4 over 3x minus 2. We can graph that now, put point at negative 2. Go up 4, right 3, or down 4, left 3. That takes me off the graph. And we'll connect that up with the line. All right, let's work on our other equation. 2x plus 3y equals 12. Move the 2x over, minus 2x minus 2x. 3y equals negative 2x plus 12. Divide every term by 3. And we get y equals negative 2 thirds x plus 4. Put a point at 4. Go down 2, right 3. It hits that point there. And I can connect them up. Straight line. But you're not done until you circle that point and write its coordinates. That's the point, 3, 2. All right. Last one, number 8, systems by substitution and elimination. So let's go along and do a lot of the evens here. When they're both set equal to y, I can just set the right-hand sides equal to each other and solve for x. So 2x plus 5 equals 3x plus 4. From here, I'm going to take 2x away from both sides. I got 5 equals x plus 7. 7 away from both sides, negative 2 equals x. You're not done. You still have to solve for y. Plug it into either spot for x. We get y equals 3 times negative 2 plus 7. Y equals negative 6 plus 7. Y equals 1. And then, as a bonus step, write it as an ordered pair. All right, so number 4. They're not both solved for a variable, but one is isolated. So I'm going to take the right-hand side, put a box around it. Do a better box. So y is equal to negative x minus 18. So y can be replaced by negative x minus 18. I'm going to replace this y here. I have negative 4x minus the quantity negative 8x minus 18 equals 10. So I've rewritten that second equation, but without the y. Instead, this plugged in. This is better. It's got the same type of variable, so they can be combined. Distribute that negative. I get negative 4x plus 8x plus 18 equals 10. I combine some like terms, get 4x plus 18 equals 10. Move the constant away from the variable. 4x equals negative 8. Divide both sides by 4. And I get x equals negative 2. We're not done. Got to plug it back in. So plug it in right here. Y equals negative 8 times negative 2 minus 18. Y equals 16 minus 18. Y equals negative 2. All right. The problem like number 6, no variable is isolated, so we have to do the work to isolate a variable. Take that top equation, x minus 5y equals negative 15. And I can isolate this x pretty easily by just adding 5y to both sides. X equals 5y minus 15. Put a box around the other side. Draw an arrow to this x right here. And we get 8 times 5y minus 15 minus 2y equals negative 6. Distribute that 8 in. Get 40y minus 8 times 15. I think that's 120. Let's just go with 120. Combine like terms. We'll get 38y. I'm going to add 120 to both sides. Equals 114. Divide both sides by 38. And I get y equals 3. Not done, even though we've done a lot of work. So I'm going to plug that back in. I'll plug it in right here is the easiest spot to plug it in. Get x equals 5 times 3 minus 15. X equals 15 minus 15. X equals 0. And then bonus step, right, is an ordered pair, 0, 3. All right. Elimination's all we got left to do. All right, with a problem like number 10, notice you already have a zero pair, so you can just go ahead and add them together. These cancel out. These here will become a negative 2y. And over here, this becomes a 16. Divide both sides by negative 2. Get y equals negative 8. Plug that back in to anywhere where we have both an x and a y. Just do this top one because it's easy. Negative 2x minus 4 times negative 8 equals 14. Negative 2x plus 32 equals 14. Minus 32 minus 32. Negative 2x equals 14 minus 32. Negative 18. Divide by negative 2, divide by negative 2, x equals 9. So, as an ordered pair, 9 comma negative 8. Let's see, 9 comma negative 8 is correct. All right, let's just do one of these last difficult ones and we'll finish this up. Let's do 16. So look for ways, so there's no zero pair and there's no quick and easy way to make a zero pair. So I'm going to look for ways to simplify these. If I divide everything in that top equation by 6, I will get negative x plus y equals negative 1. Now I can easily get a zero pair by taking this and multiplying it by, let's say, 8. That's going to create a zero pair with the x's. Now I've got negative 8x plus 8y equals negative 8. Add these together. These cancel out. I've got negative y equals negative 4. Divide both sides by negative 1. Y equals 4. I'm going to plug that back in. Maybe even right here would be a good spot. Negative x plus 4 equals negative 1. Minus 4 minus 4. Negative x equals negative 5. Divide both sides by negative 1. X equals 5. Or 5 comma 4. For number 16, 5 comma 4. Yep. All right. Well, good luck studying. Have a good rest of your day.